Okay, so I'm back. So we stopped at question 6. Just minimize this a bit. Okay, we stopped at question 6.2. So 6.1.2 says the size of ACD. So ACD. Okay. So since this is your diameter here, this angle is going to be 90 degrees. Okay. But ACD, this angle here. So at this point, I will be able to calculate this. This is also 90 here. C2, no, this 32. C2 and C3 also forms 90 degrees because there's a radius perpendicular to tangent. So at this point, I can work out C3. So C3 is going to be 90 minus 32 times 2. That is your radius perpendicular to tangent. Okay, so that is simply going to give us, let's get my calculator. $32. No, why am I saying 63? It's 26 degrees. So C3 is 26. Okay. So we said that C4 I can calculate now. So C4 is equal to 90 degrees minus C3, which is 26, minus C2, which is 32. Why? So that's angle in semicircle. Okay. So that's going to give you 90 minus 26 minus 32. Oops, 90 minus 26 minus 32. Because that's 32 degrees. There was probably an easier way to get it, but I just can't see it at this point. Okay. So there we go, 32 degrees. So the question was for ACD. So ACD is equal to ACD. It's going to be C3, which is 26, plus C4, which is 32, which gives me 58 degrees. I just realized now I went a long way around. You just explained to you what I could have done. It's only once I've got the angle I could have seen, I see now the easier way out. You see, at this point, I've got this angle here. Alright? So this angle forms 90 degrees, and they wanted this angle here. So I could have just said 90 minus 32, which is also give you 58. Why? Angle in semicircle. But okay, as I said, it's foresight there. I didn't see that. Oversight or foresight, whatever the right word is. Okay. So I'm sure you guys have gotten the quicker way out. You guys are the young minds. So number 3, 6.1.3, they want D2. So if I look at D2, D2 is the same as C4. Now at this point I have worked out C4. Okay. So C4 is equal to D2, which is equal to 32 degrees. Why? Angles opposite equal sides. This is your radius here. Okay. So that is going to be 32 degrees. No. D2 is the same as C4. But C4 is 32 degrees. Okay? Yes, that's correct. So now let's look at number 4. Let's change our color. Number 4 says O1. So looking at angle O1. Okay. So I can say exterior angle is equal to sum of two interior opposite. Okay. But then I would have to prove congruency first. Okay, so angle O1 the same as angle C2. If you don't see it, you see an angle at center, O1, is twice angle at circumference, which is T2. Can you see that? So O1 angle O1 is equal to double 32, which is 64 degrees. Why? Angle at center is twice angle at circumference. Okay, so that's 64 degrees. Just fill it in here. Okay, a lot of chasing of angles here. Then they want you to work out 6.1.5. They want you to work out D1. So again, if you look at O1, angle at center is double angle D1, which is angle at circumference. Can you see angle at center? So angle at center is twice angle at circumference. So D1 is going to be half of 64. Okay. So, or we could have gone angles in the same segment with D2. Okay. So we can say that D1, so half 64, which is 32. Angle at center. Or as we said, you could have said angles in the same segment. Okay, let's look at number 6. Number 6, they want you to work out B2. So B2 is here. We got this angle here. Let's check if I got the highlighter quickly. I'll show you what we have. Here in this triangle, we got T2. We got this angle here. This whole angle we can calculate it since we have all the angles around there. And there's B2. Okay. So let's go with that. We're going to say that P2 is equal to 180 degrees minus 32 degrees minus. Now this angle is 90 plus 32. So it's minus 90 minus 32 degrees. And the reason is sum of triangles, and it's triangle DCB. You see now why I normally say this here. Because if the diagram is so much complex, or a lot of triangles in, or a very busy triangle, by naming this here, and the examiner is trying to follow your logic, it's easy for you to make sense of what you're writing. Okay, so let's do that calculation quickly. It's going to be 180 minus 32 minus 90 minus 32. Should 26 degrees. Okay, it's simply 26 degrees. Let's look at 6.2. Let's go black. Okay, 6.2, they want to say, hence prove that COAB is a cyclic quad. So prove something cyclic quad is one of three things. Okay, either the butterfly, which I think will be the case here, because I've got a lot of lines here, or opposite angles are supplementary, or exterior angles equal to the interior opposite angle. So again, they're looking at C, we see O, A, B. So it's this triangle, this quad here. But do you see that this angle here, okay, just fill in the last calculated, which is 26 here. 26, you see, you can say your exterior angle. No, it's not extended. But what you should see is that, you see here, you got 64 here, and the same line would subtend this angle here, which is also 64. You see here the butterfly with the bow tie. Okay, so we say since O1 is equal to ACB is equal to 64. So it's that angle and that angle is 64. Okay, I'm just going to go into the next video.